Okay students, so in this class we will discuss basics of trigonometry. So first let us discuss what is the exact definition of trigonometric ratios. All of you know from 10th class the definition of sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta, right? So if you take this right angle triangle ABC, in this sin theta is opposite side which is AB by hypotenuse which is AC. Everyone knows this. What is cos theta? Cos theta is adjacent side BC by hypotenuse AC. Tan theta? Tan theta is opposite side AB by adjacent side BC. And cosecant theta is reciprocal of sin theta. Secant theta is reciprocal of cos theta. Cot theta is reciprocal of tan theta. So till here everyone knows. But actually these are not the exact definitions. Alright, these are not the exact definitions. These are definitions which are valid only for acute angles. Suppose if there is a obtuse angle, let's say. Let's draw a diagram like this. Alright, so in this triangle, if I ask you, this is some theta, what is sin theta? It's difficult, right? Because we know only how to define sin theta, cos theta, tan theta based on a right angle triangle. But there are other angles also, like obtuse angles, 120 degree, 130 degree. How do you find sin theta and cos theta for such angles? So actually we have to know the exact definition of trigonometric ratios in order to find trigonometric ratios of such angles. Okay, so what exactly are these trigonometric ratios? They are defined based on a circle. Okay, so if you all of you know, in 10th class you might have learned in coordinate geometry that there are two axes. One is x-axis, another is y-axis, and this point is called as origin. Alright, 0, 0. So now let's take a circle with center at 0, 0 and some radius r. Alright, so now if you join the origin with some point on the circle like this, okay, this particular line, you'll get one straight line and it makes some angle with respect to positive direction of x-axis, right? That angle is this angle, right? Theta 1. So sin theta 1 is defined as sin theta 1 is defined as sin theta 1 is defined as the y coordinate of this point, which is y1, divided by the radius of this circle, that is distance of this point from the origin. Okay, that is the definition of sin theta 1, and theta 1 is measured clockwise with respect to positive direction of x-axis. Now if you apply the same definition for the second angle, here you are able to see this angle. There is another line which starts from origin and goes like this all the way and stops here. Alright, and this also makes some angle, and this time it is a obtuse angle, right? Obtuse angle, that is theta 2. Let's call it theta 2. Now according to the definition of sine function, what is sin theta 2? Sin theta 2 will be the y coordinate of this point, which is y2, by the distance of this point from the origin, that is radius of the circle. Alright, so that is sin theta 2. Either way, here sin theta 1, this is y coordinate, y1 is greater than 0, radius is also greater than 0, so sin theta 1 will be positive. In second case also, y2 will be greater than 0, radius is again greater than 0, so sin theta 2 is also a positive number. But what if the angle is in third quadrant? So this is first quadrant, theta 1 is in first quadrant, theta 2 is in second quadrant, right? Actually, we don't say the angle is in second quadrant. This point x2 comma y2 is in second quadrant, so the corresponding angle we say that it is in second quadrant. Okay, what if the point is in third quadrant? Let's say somewhere here. Then this is the line, right? And this is the angle. This is theta 3, right? And let's say this point is x3 comma y3. So now sin theta 3, what do you get? Sin theta 3 is y3 by radius. If you observe, y3 will be negative because it is in third quadrant, and radius will be positive, so overall you will get it as negative number, right? Now similarly for fourth quadrant, you can guess sin theta 4 will be y4 by r. Let's say that point is somewhere here, x4 comma y4 corresponding point. y4 will be negative, radius is positive, so overall you get negative. So why I am discussing about the nature of the value for sin theta is because all of you might have heard about a very famous rule called all silver teacups. So how that rule came, we are going to learn based on these definitions. Okay, so now we have completed the definition of sin theta. Now let's define what is cos theta. Cos theta definition is very simple, very straightforward. Just like sin theta definition is y coordinate by radius, cos theta 1 definition is x1 by r. The x coordinate by the point distance from the origin. It's as simple as that. Now all other functions can be defined based on sin and cos. Let's say tan theta is what? Sin theta by cos theta. So if you divide these two, y1 by r divided by x1 by r, you get tan theta 1 as y1 by x1. So basically what is tan theta? Tan theta is y coordinate divided by x coordinate. Okay. Now similarly the other three ratios are nothing but reciprocals of sin, cos and tan. So that we are not discussing here. Now based on this information, let's see how this rule has come up. So this is the rule, all silver teacups, right? So first let's take the point in first quadrant. You know, in first quadrant all the trigonometric ratios are positive. That's why they say this is all silver. Silver means S for sin, T for tan, cups, C for cos. Okay, when we are saying sin, it also means it's reciprocal, which is cosecant. So sin and cosecant. When we are saying tan, it also means it's reciprocal, which is cot. When we say cos, it also means it's reciprocal secant. So basically in first quadrant all the trigonometric ratios will take positive values. In second quadrant sin and cosecant will take positive values. In third quadrant tan and cot will take positive values. Fourth quadrant cos and secant will take positive values. Now let's see how this is true. So in the first quadrant theta 1, this is x1 comma y1 point. Sin theta 1 is how much? Y1 by r. Both y1 and r are positive, so sin theta 1 is positive. Cos theta 1 is x1 by r. X coordinate is positive, radius is positive, so cos theta 1 is positive. Now if sin and cos both are positive, then tan will be positive, secant will be positive, cosecant will be positive, cot will be positive. Therefore all are positive. Next let's take this point x2 comma y2. This is the corresponding angle theta 2, right? So sin theta 2 is y2 by r. The y coordinate, it's positive, right? It's on positive y axis, so y2 is positive, r is positive, sin theta 2 is positive. Sin is positive in second quadrant. What about cos? Cos theta 2 is x2 by r. X coordinate is negative, right? And radius is positive, so cos is negative. Now if sin is positive and cos is negative, then tan will be negative, because tan is sin by cos. Positive by negative gives you negative. If tan is negative, cot is also negative, and if cos is negative, secant is also negative. So except sine and its reciprocal, all of the other trigonometric ratios will be negative. So therefore in this quadrant only sine and cosecant will be positive. Next, let's go to third quadrant. This is the angle corresponding to the third point, x3 comma y3, right? So sin theta 3 will be how much? x3 y3 by r. Now y coordinate is negative, radius is positive, so sin theta 3 is negative. Similarly, what can you say about cos theta 3? Cos theta 3 is x3 by r, that is also negative. What can you say about tan theta 3? Tan theta 3 is y3 by x3. y3 negative, x3 negative, so negative by negative, it's positive. So in third quadrant only tan and cot are positive. Similarly, you can check for the fourth quadrant. I am not going to do it, you check for yourself. Okay, so you just have to check in fourth quadrant, identify what is the point, assume it as x4 comma y4, and accordingly use the definitions and check how only cos and secant are positive, all others are negative. So students, we have discussed in this lecture what is the exact definition of trigonometric ratios. Those definitions we define based on a circle by taking the coordinates of the points on the circle and defining sin theta as y1 by radius, cos theta as x by radius, tan theta as y coordinate by x coordinate, and remaining trigonometric ratios are just their reciprocals. Okay, so we'll stop the lecture here.